Hello, this is video number 11, and holy moly, look what I did when you weren't looking. This is a larger example of what a region might look like as an oil field after we've done our little bag of tricks on it to make it easier to work with. Let me explain all of it, and then after I've said what this is so you know what you're looking at, I would say pause the video with this on the screen if you can, so you can copy this down and have your own example in your notes of what's going on. First of all, this little square down here, that's actually for my reference as much as yours, if not more. It's the order I want to visit the neighbors, and actually we don't even need that because the order that you visit the neighbors doesn't make any difference as long as you visit each one of them exactly once. But I'm just going to go, starting up here in the upper left corner, I'm going to go clockwise around in a circle like that. You can go the opposite direction, you can go up and down, left, right, what? I just got through saying, you can do them in any order you want, it doesn't matter. But that way I'm going to be consistent, I hope. The light blue, this is the actual two-dimensional grid here. Now I didn't draw the complete grid because part of it really doesn't count. This bouncy wall of zeros around, this zero is in square 0, 0 in my two-dimensional array. Row 0, column 0, which is why if you look at the coordinates on this, they might be faint and hard to see. But in light rust, this is column 1, row 1. This is column 2, row 1. Column 3, row 1. And the reason it starts at 1, 1 is because we've got the bouncy wall, and that also takes up space in our two-dimensional array. So there will be an entry at 0, 0. It's just that we know that that's 0. What that in effect means we're going to have to do is, as we read this in, we kind of have to shift down a row and across a column where we store the actual data in our two-dimensional array. Now then, bouncy wall of zeros, rust-colored coordinates for rows and columns. That says column, C-O-L. This says row, R-O-W. And everywhere there is a pocket, I've put a purple one, pocket purple. Maybe I can remember it that way. Every place there's a plot that does not have oil, I just left it blank. I mean, I could have filled in with zeros. That's what all the empty entries are. Those are all zeros. Okay, now I hope I've explained all that, and this, I'll step out of the picture so you've got the complete board here. You might want to pause this and copy it down. Now I've assumed that you've done that, and we're off. Let's see what happens if we apply this two-piece recursive oil exploration algorithm that we talked about last time. This is an eraser, but for now it's going to be a blindfold. I can't see the whiteboard. I can't see the whiteboard. I honestly can't. Oh, look. I hit that square right there. So that's going to be my starting point. That's the first orange star. And it would be nice if I actually had my algorithm to refer to, wouldn't it? One moment, please. I know you're here somewhere. I just saw you. Holy moly. Did I lose it? I am losing it. No! Man, it's gone. No, here it is. It's buried in a bunch of junk. Got such messy notes. Sorry about that. Well, that gave you more time to make sure that your example is completely correct. I did that on purpose. Okay, here we are. That's the one that I hit when I was blindfolded. If I'm a 0 on no part of it, a positive return immediately, that's not a 0, so we're not a base case. We're in business. So what do we do instead? I'm an oil pocket. I'm going to dry myself up. I'm going to preemptively set myself to 0 so that my neighbors don't come back and think, you know what, we found fresh oil. We've never been here before. I set myself to 0 and then tell each of my neighbors to do the same. And here we go. Away we go. Neighbor number 1, I'm starting right here. I'll come this direction, find out there's nothing, and come back. Neighbor number 2, go this direction, nothing, come back. Neighbor number 3, this direction, I found oil. Here's the trickiest part of keeping up with the recursive nature of this algorithm. This, if I had a gigantic poster board with a square hole in it, this is the only square we care anything about right now. The recursive function is focusing all of its attention, all of its effort on this one square. It's not the base case. We fell through the base case. We're still here, the implicit else. There's oil here. What do? We act like we have never been here before. This is fresh new territory, a fresh function call that's never been called before. This has oil. It's not the base case. It's not a 0. I don't immediately return. I set myself to 0 and I start exploring. I'm going to make these arrows smaller. It's really going to get ugly in a hurry. It comes up here to neighbor number 1. Nothing there comes back. It goes up to neighbor number 2. That is not the base case, so it does not immediately return. Maybe I don't even need the paper anymore. Maybe I've got this down. We'll see. It does not immediately return. What's it do? It sets itself to 0 and starts exploring, starts looking around itself. And that's the only square we pay any attention to right now. It starts going up here. Neighbor number 1. There's something there. So it's not a base case. Set myself to 0, start exploring. Oh no, I'm off the grid. Not really. Comfortable bouncy wall of zeros is going to send me right back. Base case. You see how that works? We don't have to do anything special to keep from going off the edge. We don't even test for it. That was neighbor number 1. Neighbor number 2, up here, bounce back. Neighbor number 3, up to the right, bounce back. Neighbor number 4. It's about time we got over there. Next door neighbor. Start all over again. It's like we've never been anywhere else in the grid whatsoever. This is the only square we pay any attention to. That has oil. It's not a base case. We set it to 0. And you know what? This is getting ridiculously messy. I'm just going to point at them, and you can write them down if you want. But it goes up here. Its bouncy wall comes back. Up, bounce back. To the right, up, bounce back. To the right, bounce back. To the lower right, bounce back. Now, watch this case very carefully. Straight down, neighbor number 6 is a 0, bounced back. That's why we set neighbor number 6 to 0 in the distant past, so that we wouldn't oscillate back and forth between those two ones. Infinite recursion, stack overflow, crash, segmentation fault. So neighbor number 6, it looks like there's no oil. It's just that we've already accounted for that oil. That's a better word than counted, because we're only counting deposits. We've accounted for that oil already, so it bounces back. Goes to neighbor number 7, bounces back. Look at this. Goes right back to the neighbor that jump-started it itself. Goes to neighbor number 8 and bounces back. So this square right here didn't find anybody that it was connected to. It completely gets to the end of the recursive function. That's the first time we've done that, for crying out loud. And when it hits the closing curly bracket, it returns to whoever called it. Who called it? Well, its next door neighbor called it. Its next door neighbor called it because it was neighbor number 4 for the next door neighbor. Now this one tries neighbor number 5, 0, bounce back. Neighbor number 6, 0, bounce back. Number 7, bounce back. Number 8, finally we have a winner. I'll put the arrow in there. It found a neighbor that had some oil, sets itself to 0, looks all directions, starts by going up here, back, up here, back, up here, back, over there, back, down here, back, here, back, here. Found a winner. Set yourself to 0 and look at all your neighbors. Up here, back. Oh, look. Finds one right upstairs. Neighbor number 2. Starting all over again. The hard part again, I'm telling you, clear your mind. Pretend like this is the only square that makes any difference whatsoever and run through the algorithm. We fell through the base case, so we're still here. So it's going to look at all its neighbors. Bouncy wall back, bouncy wall back, bouncy wall back. Dead neighbor back. Well, that's not very pleasant, is it? Never alive neighbor back. Down to 0 back, down to 0 back, down to 0 back. It looked at all its neighbors and found nothing. Whoops, I forgot to set that to 0. Yikes. Go back in time and set that to 0 when we first got there. So it's looked at all 8 of its neighbors, and none of them had oil, so it returns where it came from. It came from here. I'm glad I've got those arrows. Yeah, it was a good thing to leave those in. So we came back here from neighbor number 2 from the local point of view. I just got back from neighbor number 2. Let's check on neighbor number 3. 0 and back. 4 and back. 5 and back. 6 and back. 7 and back. 8 and back. I looked at all my neighbors. I don't find any additional oil, so I'll return. I was neighbor number 7 for this one. It tries neighbor number 8, but look, we've already dried up neighbor number 8. So it's not going to go that direction again. And that's all the neighbors for this. That's all the neighbors for this. And it returns back to this square, following the arrows backwards, backtracking, which happens automatically because of the stack frames in the program stack. Thank goodness we don't have to keep up with this ourselves, where we've been and where we haven't been. The system is doing that for us. That's the beauty of recursion. It keeps up with where you've been, and to go back where you came from, all you got to do is return. You don't even have to leave a breadcrumb trail or anything. All you got to do is return. Let's see. I just got back from neighbor number 1. Well, I got a lot of exploration to do. Neighbor number 2, that's a 0. 3 is a 0. 4 is a 0. 5. We pick up 5, so it comes this direction. Neighbor number 5, never been here before. Set you to 0. I remember to do it this time. Check all 8 directions. 1, 2, 3, 4, 5, 6, 7. It gets them in a weird order, doesn't it? But it does eventually get all the ones that are connected to each other when it comes this direction because it's visiting neighbor number 7. Sees that's a 1, sets it to 0. And here we go again. Starts all over, wheeling through all the neighbors. 1, 2, 3, 4, 5, 6, 7. Found a winner. Right here. Okay, start all over again. I have oil. Dry me up, set me to 0, and look at all 8 of my neighbors. Didn't get far. Neighbor number 1 is a 1. Set that to 0. Go all 8 directions. 1, 2, 3, 4, 5, 6, 7, 8. Very last chance we found one. Set you to 0. And check your neighbors. 1, 2, 3, 4, 5, 6, 7, 8. Found one. Set you to 0. And it looks like, well, why didn't it just go over here? It could, but that's not the order that I'm looking at the neighbors. I check this neighbor first, my upper left neighbor. When I do that, I find a 1, set me to 0. Here's where the bouncy wall kicks in. Less to check. Bounce off the bouncy wall. That's neighbor number 1. Neighbor number 2, I'm going to stay for a little while. Hello, neighbor number 2, set yourself to 0. Why, thank you. I think I will. That's a 0. Start all over again. Check all the neighbors. Neighbor number 1, neighbor number 2, set you to 0. Then what? Neighbor 1, 2, 3, 4, 5, 6, 7, 8. Nobody home, no more oil around me, so I'll just return where I came from. That was back from neighbor number 2. 3, 4, 5, 6, 7, 8. Using the bouncy wall. I checked all my neighbors and taking care of everything. I'll go back to where I came from. Now then, this one we just returned from neighbor number 2. Let's try neighbor number 3, 4, 5. Been there already set to a 0. 6, haven't been here. Neighbor number 6 gets set to a 0. Goes all 8 directions. 1, 2, 3, 4, 5, 6, 7, 8. Checked all the neighbors. So it's done. Goes back to where it came from. It actually came from upstairs. So we have to go back to here. And let's see, that was neighbor number 6. It tries 7, bouncy wall, 8, bouncy wall, and done. Returns back. This was only neighbor number 1 for this one. So this one's got to check 2, 3, 4, 5, 6, 7, 8. Doesn't find anything. And you can see what's going to happen the rest of these. There are no more 1s left in this deposit. Return, 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 return. Where did all this start? I returned to here. And let's see. This one came from here. That was neighbor number 1. So it's got to go back where it came from. And it tries 2, 3, 4, 5, 6, 7. Well, it's a good thing, or I would have left this one out. This is neighbor number 7. Neighbor number 7 has a 1, set it to 0. Check all 8 directions. 1, 2, 3, 4, 5, 6, 7, 8. Went all directions and came back. And it's not an accident that I'm bouncing my finger around here. It goes up here and comes back. It doesn't go up here and then go around in a circle. It goes up here, comes back. Goes there, comes back. Goes there, comes back. In other words, each one of those, listen carefully if you've been sleeping through most of this, each one of those is a separate recursive call. Each one of those is a separate recursive case. Go visit my neighbor number 1. That is one recursive call. We're back now? Okay. Now go try neighbor number 2. That's a separate recursive call. Yada, yada, yada. This recursive function is heavily recursive. It calls its recursive self 8 times, once for each neighbor. I lost my place, but I hope the errors will guide me back. This was neighbor number 7, and it goes around. It's not going to find anything. So then it returns, That was neighbor number 7 from this one. And neighbor number 8's got nothing. So it's done. And it goes back to where it came from. Oh dear, this is going to go all around the world, isn't it? Goes back here. Then that one's done. Goes back there. That one's done, goes back there. This one's done, goes back here. Well, maybe not the entire world. Let's see. This one's done, comes back here. And that's where my dot hit the board when I was blindfolded. So, ladies and gentlemen, we have gone through that whole connected set of ones in that grid. Holy moly, what a mess. Messy, 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 messy. Now, what do we do from here? We succeeded. We found a deposit. We return 1 or true. We were successful. We return 1 or true from a square that we land on that has a 1 in it, regardless of whether it's a single 1 all by itself. If it's a single 1 all by itself with nothing but zeros around it from the beginning, it still counts as a deposit. A deposit is defined to be a connected set of pockets. And if you have a 1 in you at the very beginning, you are a pocket, whether you're connected to anybody else or not. Okay? So this altogether is one deposit. We return true. And whoever called us, maybe a public wrapper? Could that be? We return true to the public wrapper and say, okay, yeah, you found a deposit. You hit the jackpot, actually. This was a huge deposit. You're going to get rich. Jeb's a millionaire. But you just count it one time. That's only one deposit. So the public wrapper is going to have to look to see if there are any more in here. That's where the public wrapper, listen to this carefully, the public wrapper is going to have the iterative global view of what's going on. It's going to have to know, well, that deposit might not be the only one. I have to keep looking to see if there's another deposit somewhere. Most of the places, almost all of this is going to be no, but look down here. This is another deposit. It's going to land on one of these ones. Actually, probably the most straightforward way for the public wrapper to go through this is to do the iterative search, going across, but it's not looking for a whole deposit. The iterative public wrapper is looking for one square that has a 1 in it. And the natural place to look would be up here at the very first square. So this is probably where our public wrapper is going to jumpstart the recursion. And it's going to get exactly the same deposit because every one of these is crawling around itself looking at all the neighbors. But it's going to start right here and do the search, and then it's going to go through all of these, all that stuff. You know what? That would be actually an excellent exercise to trace this starting right here. What does it do? What does the public wrapper do after we get back from that? And this big, massive deposit just returns 1. You found 1 deposit? Then public wrapper is going to loop to this square and see if that's the beginning of some new deposit. Then this square, then that square, then that square, yada, yada, yada. Scanning, there's the yard mowing thing. Scan, 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 scan. Find another 1 that's not been zeroed out yet. Here it is. Here's the next one it'll find. It'll set that to 0. This is going to look all directions. It will eventually find this one over here. Set that to a 0. That's going to look everywhere, find nothing. Pardon me. And return back where it came from. This will also return success, or 1, back to the public wrapper. And the public wrapper will say, 2, I found 2 deposits. And that's the solution to this. The solution to this is not to set the whole thing to 0. That would be easy. It is zeroing out. By the way, we are destroying our region. We are destroying our oil field in the search for oil because we're setting all of the 1s to 0s. We're drying up all the oil that we find in there. So it better be that we're only interested in the answer at the end because that's all we're going to have. When we trash the whole thing, set it all to 0s with our recursive algorithm, the end result will be 2. There were 2 deposits in this entire oil field. Now, this is pretty pictures, all multiple colors and everything. You might want to trace through this on your own, or maybe even watch the video again if that trace didn't make sense the first time. Ask me questions in email. Come by during office hours. Jot down questions for our class at the end of the week, which seems in a ridiculously long amount of time from now. But yeah, you got to do this stuff. You got to know this stuff. Because if you don't understand this, oh dear, Program 2 is going to give you fits. And I'm not trying to scare you. Well, maybe I am. I'll see you online.